In this video, I'm going to give a high-level walkthrough about how to use Sailemetry to analyze draft stripe data from pictures of sails. So to start with, we're going to open up the application, which has a user interface oriented towards starting at the top and working your way down towards the bottom. The first thing we need to specify is the camera sail profile for the batch of images that we want to process. So you can see here I have two separate profiles that I previously set up. One is for a GoPro Hero 11 with a wide angle lens, and then the other is for the same camera but set to linear mode. So the batch of images that I was going to demo today were taken, or the camera was set to linear mode while it was taking pictures. So we're going to select that. The next thing to specify is a camera calibration file for the day. So for these batch of images, I actually can skip this step because the GoPro Hero linear mode has already removed the fisheye effect from the camera for me. However, if I was using the wide angle lens, the wide angle mode for my sail images, then I would want to load a calibration file that's specific to that camera lens, so that Sailemetry can actually distort the images to remove the fisheye effect for me. So I'll go through the process to create calibration files in a separate video. And I'll actually just switch this back to linear because, as I said, we're processing pictures that don't have the fisheye effect in them. So the next thing to do is to choose a directory of images that we want to process. So the images I have today are on a just an SD card that I have plugged into my computer. So I'm just going to select I want this whole directory, and then it's going to load all those images for me into the software. So the next thing to do is setting a couple sample images that the software can use to know what is a stripe versus everything else in the scene of the picture. So if I go to this manager, we have the option for it to either pull up a random image for me, or I can choose an image that I'm interested to serve as a sample of the day of sailing. So I'm going to click on this. I'll go into the directory of all the images that were loaded. And to start with, I'll just choose one of these pictures of me going upwind early on in the session. So you basically have three track bars that you use to isolate the draft stripes from everything else. And the variables that these track bars correspond to is hue and saturation. So to explain a little bit more about what those are, your min hue and max hue is basically setting the range of color that correspond to the images you want to threshold. So in this image here, my draft stripes are orange. We basically want to set a minimum value and a maximum value to take a slice of this sort of color circumference that corresponds to the color orange. And then the second thing that we can change is the saturation band. So something with high saturation is going to correspond to a very pure color. So a very strong red or a very strong blue, just as an example. Whereas a very low saturation means there's a lot of white inside the color. In the context of these sample sail images, that usually corresponds to there's a lot of sun glare inside those pixels. So to demonstrate the process to set these bands, you usually want to start off with the min hue. However, the color orange happens to correspond to close to zero hue. As I move this bar up, you'll see very quickly it's starting to cut out some of the pixels of the stripe at the top of my sail. So I actually want to bring this back down to be close to zero. And then we'll set the max hue. And as I start to pull this down, you'll see it's progressively cutting out different groups of colors until it gets down to my stripe. So moving down, it first cuts out the blue from the background. Then you'll see it'll start to cut out green and yellows until it gets down to the upper band for orange. So if we go all the way down to 12, you'll see it started to remove the stripe colors that are closer to yellow. So this was too far. We're going to move this back up to be a little bit higher so that all the pixels for our stripes are still intact. And then the final thing we'll do is set a minimum saturation band to get rid of all this glare that's being picked up from the middle of the sail. So once I get up to around 60 here, it happens for this set of lighting conditions with this particular sail. Min saturation of around 47 is fine. Just to demonstrate what this would look like if I set the saturation band to be too high, eventually it'll start to get rid of some of the pixels corresponding to our stripes. So like once I get close to 120, you're seeing it's cutting away some of the pixels from the bottom to the top stripe. Our sort of goal here is we want to see just the stripes and nothing else. If you see a couple specks around, that's totally fine. We really just want to make sure that the stripes themselves are intact. And there's some basic logic inside the application to sort of filter out noise if we have some scattered dots around. Like even if I were to move this down, you can see that there's some scatter that's starting to show up here. That's actually still fine. The main thing is we don't want a lot of noise or a lot of pixels to be picked up around the stripes. So we'll submit this image and it'll save this as a sample image to be referenced when it's processing. Generally, you want to have at least one image of you sailing upwind and one image of you sailing downwind, because the lighting conditions that the sail or that the camera sees upwind and downwind will usually be quite different, just because the location of the sun is shifted when you're going upwind versus downwind. So we'll sort of just scroll through here and try to see if we can find a good image of going downwind to use as a reference. Yeah, this one's pretty good. So here we can see the sun's at a very different angle to the sail than the first sample image that we used. And as a result, the lighting is quite different. So we'll still go through the process of setting the color bands. You can see that the color orange, or that our min hue, we can actually set higher until it starts to cut out the stripes, just because the colors are shifted more towards yellow. So I still want to make sure I'm not cutting out any of the stripe pixels. So I'll maybe move this up to 5 or 6. And then similar, we'll next move on to the max hue. And let's say that this looks pretty good here. Like I went too far if I go to max hue of 17, or even really like a max hue of 21, you can see some of this stripe is getting cut out. So we'll set this up. I'd say this looks good here. and then we'll set the saturation, which is a lot lower just because there's a lot more saturation on the image directly, generally speaking, than the first image that we sampled. So I'd say that this looks pretty good. And as you can see, we've isolated the draft stripes with only a saturation of 31, which is a lot lower than the previous image that we had. So this is good for today in terms of our sample images. If you sail, say, another day with the same camera and the same sail that was also quite sunny, you actually don't need to do more sample thresholds than this. It's only if you go out on different days where the lighting conditions are quite different, you'll need to set different parameters or different thresholds according to those lighting scenes. So say you go out on a day where it's quite cloudy, the next day you sail, then when you come to analyze your draft stripes, you'll want to open up the manager again and sample a couple more. Otherwise, you can just proceed using these two images as a reference. So we'll close this. And then there's a couple sort of more minor settings to choose before you start processing. So first one is whether the software should create copies of the images that you load into it with data overlaid on top of it. Really, the only reason not to click yes here is if you're running out of storage space on your computer and you only care about the output CSV file. Processing type, it's usually fine to just leave this set to multi-threaded. You can look inside our docs for more information about the other options. TAC of sail images. So these pictures were actually taken on port TAC. So we want to switch that to port so that our twist numbers are going to be correct. Number of draft stripes on each sail, this will always default to 3. But if you were taking images for processing images where your sail had 2 stripes or 4 stripes, you could specify that here. Cropping balance, you can actually leave this alone to its default setting. We're actually planning to deprecate or phase out this setting in the future, so don't need to worry about that. And then twist correction, this is a tool that allows you to zero out your twist calculations off of a known reference that you see in the pictures. So usually, especially if you put your camera on the deck of the boat, it's quite difficult to make sure that the camera is aligned perfectly with the fore-aft axis of the boat. But there's usually good references that you have to note what is supposed to be 0 degrees. And this tool allows us to select that. So in this sample image that I brought up, I know that what we're looking at here is the prodder on a moth sail. I know that this edge is in line with the fore-aft axis of the boat. So all I need to do is specify 2 points that are supposed to be along 0 degrees, and it will figure out what the twist correction is supposed to be to adjust the twist calculations of the sail, and then also entry angle and exit angles. So this is going to subtract the degree measurements by -4 degrees. We can click submit, and then this will pop, or this will be specified inside our twist correction window. Something to note is that say you have a boat where you don't have a reference that is exactly 0 degrees, but you have a reference that you know it's some degrees away from 0. As an example, say we wanted to use the spreader, and we knew that this was supposed to be 40 degrees away from 0. It's just a matter of clicking on 2 points here. This will say the twist correction is 42 degrees. We can submit that, and then if we know that it's supposed to be 0 or supposed to be 40 degrees away from its reference datum, then we could just do some math here and figure out 42 minus 40. It's supposed to be around +2 degrees. So that'll be specific to your class and what the camera sees. Because the moth has that 0-degree datum to start with, like already, we'll just go back to what it used to be, which was around, I think it was -4.15. And then the next thing we need to do is specify the place where the software will output the data. So you can put this anywhere. I'll just, for this demo, create a sample directory on my desktop. We're going to choose this folder, and then we hit the start button. So we'll get this pop-up saying no camera calibration file was loaded. Do you want to proceed? This is mainly just a sanity check that you didn't forget to upload, or sorry, you didn't forget to load a camera calibration file when you intended to. As I was saying earlier inside the video, the images that we're processing already have the fisheye effect removed, so we're just going to hit yes. But if you had selected a camera sale profile that's supposed to have images or supposed to have the fisheye effect filtered out or calibrated against, then that pop-up could remind you to load the file before you proceed. So we see that there's a track bar here that's basically showing the progress of it processing all of the images. Even before the program finishes, we can go check out what's being written into this directory. So you see there's 2 CSV files. One of them has just the raw data of all of the stripe information that could be found on the different images that were loaded in. And then this data overlaid images directory basically shows us copies of all the images that were loaded into the software with data, with the stripes traced and data placed on top of it. So for this one image, as just as an example, we can see it picked out the stripes properly, and the calculated data associated with each stripe is written here, where the top first number corresponds to the top stripe, and then it goes progressively down to correspond with the lower stripes in the image. So whenever this track bar gets to 100% or it gets all the way to the end, we know that this finished. And then, yeah, it's just a matter of looking through these images or overlaying the output data in whatever application you choose from. This file is actually ready to be loaded straight into telemetry overlay if you want to overlay your data on top of other footage, or you can load it into Sailemetry or other data analysis tools as you please.